very slow. Okay, so Solaris was established at CMIN 22 at the end of 2022, 18 months ago. And as part of the technology development program of the technical directorate called GSTP. And since then, we've been implementing a wide range of activities. The scope of Solaris is quite broad. We're one of the few space-based solar power R&D programs which has really taken a holistic view with regards to the preparatory work that needs to be done in order to get enough information together to understand if we should go ahead with a full development program. So this includes not just concept studies and the key technologies, but also scientific research activities around space-based solar power and its feasibility and its effect on the environment, and crucially, the whole partnership building aspect of developing the knowledge, the awareness that's required in new fields, new areas like the energy sector and the energy side of governments, which have not been engaged necessarily significantly in the space sector in the past. So bringing the awareness of this new capability towards those future stakeholders and trying to convince them that they ought to pay attention to this emergent technology because they will have a crucial role in the future. So really preparing the ground for the partnerships that are going to be needed to take forward something as ambitious and at the scale of space-based solar power. So a quick overview on these 4 different areas. System studies, we completed 2 pre-phase A concept studies with industry at the end of 2022 on new technical concepts for how to do space-based solar power in Europe. We haven't looked at this for over 20 years in Europe in terms of the concepts of how we might do this. So I'm happy to announce we have 2 new reference architectures. These were led by consortiums in Italy. Thales Alenia Space in Italy led one consortium looking at an RF power beaming concept for space-based solar power. That's on the right. And then we had another consortium led by Arthur D. Little, a management consultancy from France, that was working with Thales Alenia Space in France to look at an alternative way to get energy down from space, which is something that you may not be aware of and not many agencies or companies around the world are looking at right now, which is to reflect natural sunlight with large-scale mirrors in orbit onto the existing terrestrial and future terrestrial solar farms on the Earth. So this was one of the 2 studies that we did in parallel last year, and we've been quite pleasantly surprised at the promise of this technology and this way of getting energy down from space. And without stealing the thunder from the presentations that will come later this morning about these 2 concepts from the contractors who did the work, I'll just say that we think at ESA that there is a place in the future for both of these concepts of delivering energy down from space, each with their advantages and disadvantages, as you'll hear about a little bit more. And all of the documentation from these studies have been made publicly available on our website. So please do feel free. The links are provided below when you get the presentations to look at the full technical results from these studies. Now, in terms of studies, the other critical enabling capability is, of course, the launch systems. And we initiated last year and completed last year 2 parallel studies on European concepts for heavy lift, low cost, high cadence launch systems, which would be needed in order to enable space-based solar power and other such applications. These were done, one by Ariane Group in France and the other one by Rocket Factory Augsburg in Germany. These studies have been completed as well, and you'll hear about them in a talk tomorrow. In terms of technology activities, we have quite an ambitious technology development plan for Solaris. And I'm happy to announce today that the first activity related to robotics, interfaces, tools, and methods has been issued in terms of an invitation to tender, a €3 million activity funded by the UK Space Agency. Unfortunately, therefore restricted only to UK industry to respond to this activity. And this will develop the methodologies and the tools that will be needed for the robotic systems that will be required to assemble these large structures in space. So the ITT is open now. If you're interested in this activity, you have still a month or so to go to respond to this, and we look forward to proposals from industry in this area. Next, on the topic of research activities, so these are not technology activities per se, but the scientific research that we need to do to fill in some knowledge gaps, like how would power beaming affect the Earth's atmosphere? What would the implications be for human health and safety, animals, plants, flora and fauna, and all of those things? So we have put out a call last year to the community to propose ideas for research activities. And I'm happy to announce today that out of these 5 different areas that we had identified, we've received proposals and selected contracts to go forward with now for 3 of these areas, starting with the ionosphere and atmospheric interactions. So you see here two contracts with academia and industry to work on looking at the effects of microwaves on the ionosphere and atmosphere. And then in the topic of launch and deployment, life cycle analysis in particular, how would the launches affect the atmosphere and the environmental sustainability of space-based solar power? We have starting a new contract with industry and academia on the green credentials of Solaris, looking at the life cycle analysis. And finally, on the interference aspect, which you'll hear a lot about with the radio frequency spectrum interference of other uses. This is a key aspect that needs to be looked into. How are we going to avoid space-based solar power interfering with others and make it compatible? We're starting a research activity in Portugal here with a very strong group working over there. Now, what's missing in the sets of proposals that we got, which are not covered yet, are the crucial areas of human health and environment, so flora and fauna. So these are not covered so far in our research program, and we encourage the community, if anyone is interested and has the expertise to investigate these topics, we're still welcoming ideas and proposals into our basic research program for covering these areas. And this could also be an opportunity for international partnership if there are other agencies around the world who are looking at this topic as well, because these are questions that all of the whole community is going to commonly face that we need to find answers to. Now, getting towards the end on the last topic of stakeholder engagement. So this slide, I'm not going to go through all the details. I put it here as a distillation of our experience in Solaris over the last 2.5 years, discussing and interacting with a wide range of stakeholders from both the space and energy side all across Europe and indeed internationally. But this is really a focus on the feedback we've had and the experience we've had with European stakeholders, public, private, space and energy. Lessons learned from what we've discovered talking to all of these people, and where the successes have been with raising interest and where we found challenges. So I just want to highlight a few of them. Now, on the success side, with space and energy, we've seen and you've heard about the acknowledgement by the UK government, by various departments on the value of space-based solar power and a joined-up approach in trying to take this further. So this has been a great success, I would say. And unfortunately, the rest of Europe is still not quite there yet. The other aspect is on the energy sector side. We've talked to a lot of energy sector players, and overall the feedback has been extremely positive in terms of them seeing the value proposition of space-based solar power. And we've had quite recently, in fact last month, a major energy sector player from France, ENGIE, who published about on their website and on social media about their interest in space-based solar power through the work that they did with ESA last year on one of the concept studies. And as far as I'm aware, this is the first time an major energy sector player has publicly acknowledged interest in space-based solar power. Not a space agency or a space company, but an energy sector player. This was for the reflector concept of delivering power from space. So I think we need more of these kinds of public statements from the energy sector, seeing the value of space-based solar power to help the space sector people understand that the customers for this technology are really valuing seeing further work done on this. On the space sector side, the challenges have been indeed to to make them see the value proposition and see beyond just the huge challenges which they are fully aware of in terms of the space technical challenges out there. And so this is work ahead that we have, I think, to convince the space community and the space stakeholders that the value proposition is really high, and we have a duty and responsibility to do that technical de-risking in the near term. Yes, I'm going to finish. Where we've also had great success in terms of exposure is with the media internationally and even across Europe. And we were represented at COP28 in Dubai last year for the first time. Space-based solar power was there on a pavilion being talked about at COP28, which was fantastic. And we continue to get a lot of media interest about this topic right now. So it's getting into the public consciousness, and that's a good thing that people are talking about it. Now, this was our nominal roadmap at ESA and Europe. If we had completed Space Solaris by the end of next year and been prepared to make a decision to go ahead, this is how we would have gone about it. But as I said, we've been quite limited in our funding for Solaris so far since the ministerial, and it's seeming quite challenging to see how we could complete the activities that we had planned by the end of next year to really make an informed decision about going ahead. But that's still part of internal decision-making about what our approach will be for the ministerial next year. And with that, I'll finish now and just say that Solaris has turned out not just to be a plan of a number of different activities to inform space-based solar power, but it's become really a vision for the future in terms of what energy from space can provide for the world, not just for the climate crisis in the short term, but even for human development in the longer term as our needs for clean energy grows. So thank you very much.